parts have arrived. Good day, everybody. Morning, evening. Parts have arrived from Mouser for the Atwater Kent. Yes, sir. Big box of parts. $60 worth of parts. Included in these parts are these 0.047 microfarad 630 volt capacitors. To go inside these. In some previous video, probably one or two, I mentioned that I wasn't going to touch these. I was going to just not use these anymore. Well, I changed my mind. At least at this point, I've changed my mind. If you can see that, I've been experimenting. Proof of concept. This is what I started with right there. If you can see the light right there, you see that? It's still got wax in it. That doesn't. I think I've seen some videos on this, and I honestly don't remember exactly what they did. But basically, I used two things. Trusty old drill master. What? Okay, Drill Master dual temperature heat gun, Harbor Freight special, and a pair of my yellow Kleins, and a blue shop towel. I'm going to move you down here, turn my viewfinder while I can see. Not quite sure how I'm going to refill this thing. I think I'm just going to find a... I ain't figured out how I'm going to do this yet. One thing at a time. Let's see if we... I'm just going to see... I'm going to heat this thing up. Whoop. Low heat, low heat, low heat. You got to make it low and slow. I noticed on the first one I did here, is it just kind of... See? I'm getting the drip out on it. Low and slow. It's like a plug in there, and it just, what the other one did is it just got hot, and all of a sudden it just came right out. Just like this one's doing. As you can see that, you see the shiny part, that's what the objective. I got to get that out next. The first step was just getting the plugs out of there. So we'll shut it off a minute and see how I can get that out. I'll bring you back if anything worth reporting. Alright, I got the capacitor, if you can see my finger there. I've got the capacitor chucked up in my little pen of ice. What you see there, tighten it down. What you see there, that silver is a blob of solder. So these leads right here are soldered to that, I believe. I'm still figuring this out as I go. So I'm about to attempt to unsolder that, see if I can get that part of the wire out. Or the lead, should I say. So let's see what happens. Can you see? Okay, here we go. It definitely solder and it definitely come out. Now, I hate being zoomed in that far. There, if I can see it, there is the non-inductive lead. So now I'm just going to take it out. I'm going to zoom you back because I know I'm fixing to go out of. I'm going to take said capacitor. Where am I? Good Lord, I hate it when I zoom out this far. Golly, I'm zooming way out to the moon. Ooh, let's just go in a little bit more so you only see. Basically now, that I've got the lead out, if you can see it. Yeah, I'm having trouble. There we go. I'm going to take that, heat it up, and just bounce it on my work table. Now I see the inside of the capacitor. Then I'm going to do the same thing for the other side. I'm going to chuck it back in my vise, panel vise, should I say. Okay, so far so good. I'm going to do the same thing. I'm going to melt the solder off that side. Stuff kind of smells like a firecracker. Somebody's texting me. That'll be about a back and forth for 20 minutes. Okay, I don't know if y'all can see it or not, but a little metal in there. It looked like a metal tab. I guess the outside full. So it's 2 metal tabs. So now, like when he finally caught the Roadrunner, says, now what do I do? So a little bit of oh boy, got something out of it. Reminds me of a firecracker inside this thing. I'm sure it's pretty delicate. So just really experimenting to see if I want to really, I said I wasn't going to do this, if you remember. Alright. I've got the tabs out of the way, so now what do I want to do? I'm thinking, hold that thought. I know, thinking wakens, I'm not supposed to think, it'll weaken the nation, right? What I'm looking for is something that'll fit in there. Oh, hang on. Method to my madness, folks. This is live. Oh my gosh. Trying to find something that will go in there. Look. My Exolite nut driver set. Now I'm going to fix this in a vise. Let me see if I can find a suitable vise. Something a little bit more horsepower than this panel vise. This might work. Let's try it. Let's see. Can y'all see? Yeah. So let me tighten this thing down a little bit more. Let me think about this a minute. Hold that thought, I gotta go get a pair of gloves. Okay, I have reappeared. I haven't run off with the gypsies yet. Alright, well, let's see. Let me make sure all this is going to be in frame. I don't want to be accused of making crappy videos. Even though I am from the South and I talk like I'm from the South. I can't deny. So I guess what I'm going to do, use low heat again. I don't think you got to have lots of heat, but I'm just going to take, and I want to heat this capacitor. And just kind of push down on it while it's inside that screwdriver. I don't know if this is going to work or not. I think my fingers are... I want to do this. See, this is why I really didn't want to do this. I need to be able to hold this. Let's try again. Take two. I'm going to try this. I'm just trying to get it warm without. See if I could break that. Get it hot, like it's. I can see it bubbling inside. Alright, I can turn that stupid thing off. I'm going to attempt to push it out, and look at there. Voila! It came out. I'm really impressed. I don't know where the stupid thing went. Rolling around on my floor somewhere. I'll be dang. Look, no more capacitor. I got an intact capacitor too. I'd love to know where the old piece went. You ever had stuff just fall and just like disappear, just evaporate into nothing? Ladies and gentlemen, this is what this capacitor guts did. It went somewhere and just disintegrated. And I'm super OCD. If I had my glasses, I could do something. I don't even know what I did with my glasses. Having a meltdown. Be right back. Okay, finally, I found it. Went where you would least expect it. And here it is. That's the inside of that capacitor, if you can see it. Look at there. Just wax paper wherever the cotton picking thing is. Unwind it and fix it and put it back together, I guess. Yep, that's what's inside one of these if you didn't really know. Zoom out. At least you see something. There's the one full, the inside full, and the outside full. And it's just wound around this little waxy paper right here, which is the dielectric. Separates one side from the other, all it's supposed to do. So now, if you didn't see a minute ago, there's your core. That capacitor is now free to roam about the city. And all I simply did, use a heat gun on a low speed, heated the end real low and slow. You ain't got to do this fast, apparently. It melted the ends out first. Then I was able to go in and unsolder the leads from inside, got the leads out of the way. Once I did that, then I pulled the little metal tabs out, if I can find them, right here. You'll see them. That's what connected to the solder. Anyway, pull these tabs out, got them out of the way, and then I was able to take, let's see here, what is this stupid thing? 3/16. This is a 3/16 nut driver. This piece right here, this is out of my Exolite 99 PS50 screwdriver and nut driver set, USA, 13 pieces. It just does fit in there, see? Perfect. I use this to hold this up with, heat it with a heat gun as you saw. Wore a pair of protective gloves. When I saw the wax melting inside here, I will turn the heat off, took my hand and just gently pushed this thing out, and the whole cotton picking thing came out as you saw. Alright, that one's ready. Now let's see what it's going to take. Because I'm doing this for the first time, I've never restuffed one of these capacitors before. And like I say, this is the learning channel for a minute. Of course, I don't talk about stuff that learning channel is nowadays. I certainly don't want to learn anything them people has to teach. I can tell you that. I'm sorry if some of y'all might get offended by that, but Alright, there's, see if the capacitor that I bought will fit. Yoo-hoo! Now, I'm not just going to simply stick this capacitor in there without knowing something very important. Something very, very important. Some of you guys that's been doing this 1,000 years knows what I'm talking about. If you could see, let me see here, I can barely see the thing. Right there. You see that little line? It's underneath the value. That's a line. You know that line isn't there just for looks. That line is there to tell you that that is the outside foil of this capacitor. Okay? Remember how this thing was wound up now? Remember this? Inside foil, outside foil. The outside foil was the longest of the two. The outside foil connects to the lead that's closest to that line that I just showed you, or that dash or line, whatever you choose to call it. What that is you hook that to the low impedance side or ground side of the circuit that you're working on. In other words, if this was this is a bypass capacitor, okay? This is what, hang on, that's what this is a bypass capacitor. It takes any from the B plus circuit, goes through a drop-in resistor to the tube of the amplifier. It has to have a bypass cap on that, on where it goes into that tube, or in that where it comes off that drop-in resistor. It uses a bypass. Well, that is bypass to ground. Well, the ground side should connect to the outside shield, or the outside foil, should I say. That is for noise immunity. Let's say you're using this in a between the say like an audio output tube, the input grid or the control grid of an audio output tube, and we'll say the volume control. Okay. The grid of the tube is a high impedance, has a real high impedance, okay? You know, like probably 100 mega ohms or more, really high impedance. But the volume control is usually 50 to 100,000 ohms. So if you take the resistance of the volume control versus the resistance of the grid itself of the tube, the grid is very high resistance in relation to the volume control, okay? So this capacitor would go to the center of the volume control if this was a coupling cap, okay? So same thing, the foil always goes to the low side, or the low resistance or impedance side of the circuit. So the volume, so in other words, if you had the foil on the connected to the grid side, then it would act as a little antenna, and if it will pick up every piece of noise in this neighborhood. It'll pick up noise from your filament string, or if your AC line is running nearby, it'll pick up noise from that. It would pick up noise and just possibly oscillate. So this foil shield is very important, and you have to identify it on these capacitors. There's no identification. They don't put the shield markings on here, or the foil outer foil markings on these capacitors. So I'm going to set up, and I'll show you a simple way, relatively simple way of testing this. And a lot of people in their videos have went through this too. So we need to identify the foil shield of this capacitor before we proceed with the stuffing part of this video. So with that being said, I'm going to shut you down a minute, and I'm going to set up for the test, and I'll show you how I do it. It's cheap and dirty, but it works. So I'll bring you back in a few minutes. Bye. Okay, I think I got you there. Let's turn that intensity down. This is my trusty Textronics 2246 100 megahertz oscilloscope. What you need to do this. Doesn't have to be the Textronics, it can be any scope, okay? So what we need here is a scope with a decent test lead, and we need something black a black permanent, where's my screen at? A black marker pen. Probe, 10100 probe. Okay? So what we simply do, I'm going to widen y'all out just a little bit for a minute. All we simply do, we take this capacitor. We take the ground side of your probe and just hook it to one side, and what I like to do, I like to go about a ½ inch from the side right there. And I'm going to connect my positive side of my probe to the exact same distance away on the other side. Now, with all that being said, put it on ×1, hold the probe without touching any metal part of this probe and keep it away. Keep your hand you'll hold the probe in away from what you're testing. Okay? What you want to do is you want to just pinch. Boy, this is going to be weird. You want to pinch this capacitor right in the middle. Okay? So I'm going to pinch this capacitor. Now I'm going to take this other hand. I'm going to bring my vertical division up so I can get a signal. Let's see. Wow. Now, let's see if I can figure out how to zoom you guys in. Let's see, that looks like that's, yeah, that phosphor. I think you can see the signal. It's hard for me to tell, but anyway, I'm pinching it, and you can just barely see a little squiggle of a waveform there. Okay, so keep that waveform value. Keep that referenced in your mind what the value is of this. This thing is on the 2 millivolts per division, which is as low as my scope will go. So I'm on the 2 millivolts per division. So I'm probably about 0.05 millivolts. Anyway, just take a mental note of how big the waveform is. You ain't got to go to all that math and all that math. Now what you do is you turn your capacitor around, swap the leads, and have them exactly like you did just a minute ago. Now look, I hope you can see this. See the value increased? Now that means the positive point of your probe is on the full side. The reason that the signal level went up is because the full side is now connected to where your test lead is. So now you can see where it's picking up the outside interference. In your inner part of your capacitor, the inner foil, or the shielded part, I guess you could say, is on the ground side. So if I turn this back around, how I had it to begin with originally, this side right here, wherever it is, that is your foil side, or your, back it out a little bit. That is the side right there. That is your excuse me, I had a bit of coughing a while ago. I couldn't stop. I bet I coughed for 20 minutes. Anyway, this is the side you're looking for. This is your full, outer full side right here. So all you simply do, now that you know which side is which, you just take this pen and put you a little dot right there. Now that tells you where your outer foil is. In other words, this is the side that you want to be on the ground side, or the low resistor / impedance side. And this is the side here for the high impedance side. This outer foil right here will shield the center foil and keep you from picking up stray signals. Hope I didn't make that overly complicated, which I tend to do. Alright, so what do we do now? Find that capacitor. So now that I know that, where am I? I'm having such trouble finding my viewfinder. Today, I've got to find those holes again. Let me clean this up. Here's the capacitor, the shell of the old capacitor. Here's the full side right here. Okay, so somehow or another I got to get these in there. That's the next hurdle. So I'm not sure how I want to do this. I guess we'll just move you over a little bit. I'm going to zoom you out a little bit, and let's see here, turn you around a little bit. So I'm just bent the lead a little bit, if you can see that. Bent the lead, and I'm going to push this into that hole, if you can see it. And let's see what happens. Thing reminds me of an old-fashioned firecracker. Do not force this. The leads are coming out the side of this. This is how it was. I'm not sure this is how I want to go. This is all experimental at this point. Which is fine. I can do that side. I'm just not sure how I can do the other side. Oh well. May have just done it for me. I'm not sure how I want to go about this. I think what I'll do is, when I was trying to bend the lead, it just pulled right through the end. So okay, well, it's a happy accident. I mean, something, got to be happy about something, right? So this is new to me, okay? I'm making it up as I go. You know, and if some of you've never done this before, well, you get to see how I just took my X-Acto, did the same thing here. Alright, well, there you go. Now what do? I need something to put back in here, don't I? I don't have anything. I could get some hot glue maybe. How would that look? I don't have any wax. Hot glue. I wonder how hot glue and wax get along. Hey, you know what? This is what this channel is all about, learning. You know, and you got to start somewhere. So I'm going to stop you a minute. I'm going to get my hot glue gun going, and I'm going to put a little hot glue in this dude, and let's see what happens. All I can do is not work. Might lose a capacitor out of it. We'll find out. Let me plug my hot glue gun in and get it hot, warmed up, and we'll go from there. Be right back. Alright, here we go. Not sure where I want to position you guys. I'm sure y'all get tired of seeing my face. Well, we got the Arrow hot glue gun, professional series. And we got some hot glue percolating here. So we have the capacitor with the old capacitor, the old capacitor shell with the new capacitor stuck in it. So I'm going to take hot glue, shove it down that hole, and see what happens. Sucker may blow up. Here we go. Do y'all want to watch? Let me turn that down a little bit. Here we go. Okay. We are recording. This is live. Let's see what happens. It could go boom. It is filled up. It's not all the way filled up, but it's filled in the end. That way it's going to be hard to see. I'm going to let it cool off. Let it solidify a little bit. I'm liking it. I just want to harden it, because when I turn it upside down to the other side, I don't want it dripping out and looking dumb. Well, I'm thinking we got a successful stuff here. I wasn't going to do this, like I said a little while ago. I wasn't going to restuff these things, but I couldn't help it. I don't know what I'm going to do about the resistors, but all right, we're going to stuff. We're going to do the other side here. I'm going to put a little bit more in here to kind of reinforce the edges of this thing, because it's tending to want to come apart. I'm going to put a little bit more in it. Okay. I don't know if this is going to work or not. The wax and this stuff together, I have no clue. That's what it looks like. Can y'all see it? It looks rather good. And I may have to I don't have all the materials that some of these guys that restore these things do. I'm not really a collector. I'll go to a flea market or something like that, see a piece of electronic equipment that I like or something, you know, I might. But I saw this radio in the flea market. Hey, that's an Atwater Kent. I want one. I want it. I think this is going to work out good. I'm going to let that solidify a little longer, let it harden up good before I do anything else with it. I think this is good enough. So I'm going to let this solidify, just chill out for a little bit, and then I'll bring you back, okay? See you in a minute. Alright, not a lot of time passed through there, but I think it looks really good. I think I'm going to go for 98% success on this. I think there were some people that used some old capacitors that apparently there were some collectors that restore these things that when they take these capacitors apart, they melt all that glue and they collect it and then they clean it. And I think you probably could do a little bit of Google search, not Google searching, but on some of these forums, you probably find somebody that has some of this glue. But hey, you know what? I think that's going to work. I think the hot glue will do a satisfactory job. I have a new capacitor inside. The leads should be long enough. It looks 99% original to me. I'm going to roll with it. With that in mind, like, now what? That capacitor, if you can see this chassis, where is my pointer? Always losing my pointer. If you can see it, let me get line. That capacitor comes from right there. This is the ground side. If you can see it, I hope y'all can see this. I'm not disappointed. This is the ground side. This is the ground lug. If you can see it, the little ground messenger comes right up here, and these three capacitors right here were grounded to the same point. Okay, that capacitor came over here and somewhere, tied into somewhere, but that's where this capacitor I just redone is going to go. So now I got to figure out where that went. I think it went right here. Anyway, I'm going to put that one in. I'd like to take all these out at once, so I'm probably just going to take all these, take close pictures, do a little few drawings, and go ahead and take these capacitors out. This one here, this one, this one. Take these out, and may as well take all of these out, and go ahead and make sure I know what they are so I can get the components right. And I think I'm going ahead and restuff them, and then I can put them all back in here. Of course, I ordered my I ordered number 20 hookup wire, stranded hookup wire, number 20, stranded rubber wire. I got red, white, blue, green, yellow, brown, black, got them in 25-foot spools. I didn't think it was too bad. I hope it's 600 volt rating. You got to make sure you use 600 volt rating wire on these things. So anyway, I'm going to do that next. I'm going to pull these capacitors out and mark where exactly, take pictures, mark exactly where these things come from and how they were dressed, and all this stuff, and restuff them and put them back in. And I guess when I get to do that, I will bring you back. All right, stay tuned. Same bat time, same bat channel. Well, in the time that you last saw me, got a little interesting there. I started checking these capacitors, marking where they were, trying to make notes of their lead locations and all that. And I made a nice little, let's see if you can see this. I took a picture of it, and so I could use it as a reference. Okay, if that makes any sense to you. Let me close this pen up so it dries out. Anyway, I marked every one of these capacitors in red ink and what the numbers were. But anyway, during all this, when I started looking at it, and I saw this first capacitor that oh, and let me show you guys something. This capacitor that I just restuffed or repaired or made new, whatever. It's a 101. Well, I thought it was C14, and when I got to look in, C14's a 409. I'm like, oh my God, I put this stupid 047 where an 01's supposed to go. But it wasn't. That C4, that 101 that I have here come out of a different circuit, not that circuit, that capacitor that I first showed you where it goes. I was wrong. That was a capacitor out of a different branch. Like, oh my God! So I had to sit down after I took this picture, and I had to look at the values on them, and I had to there's on the schematic. Let me see if I can find it. It's playing show and tell here. Let me see. On the schematic, they actually have a parts placement diagram. Imagine that, boy. I tell you what, that has been a lifesaver. Ooh, where's my pointer? Anyway, let me see here. This is it right here, this capacitor. That's C14. That's the one I thought I was restuffing. But the C14, it has a value wrote on there, but it's so blurry I can't see what it is. But anyway, C14. Okay. Right there is where it goes. That's where it lives. And I drew the connection points. It goes to this connection point. I don't need to know the colors. I just need to know where. And this is the ground point. If you can see it, that is a central ground for 4 capacitors tie right there and goes to this ground. Good to know. Anyway, I went ahead and identified so much glare there. There you go. How's that? That good, guys? I identified the number of each capacitor. That way I could just snip the capacitors out, go ahead and restuff all of them how they're supposed to be, and have them back in line when I'm ready to put them back in. So now I have a reference. I have my values. If you can see it, the glare is horrendous. Got my values. I also have my Atwater Kent, if you can see it, Atwater Kent. You can go to the website. I had to find the URL and paste it in the video if I don't forget. This right here tells me, like the 101 that you saw just a minute ago, like C9, it's 101. Or like in this case, this capacitor, you won't be able to see it, but this capacitor that I restuffed is I believe it was Yeah, a 101 of all things. 101. That means nothing as far as any codes other than Kenwood. Atwater Kent. Let me move that up a little bit. See my eyes. Anyway, if you can read that, let me see. I'm very hyper for a 60-year-old. Well, I hope y'all can see this. 101. And it gives you, it's a 0.05, non-inductive at 100 volts. If you can see it. Now, I'm not worried about inductive or non-inductive. I can't see where it makes that much difference. It's still a roll of foil in between dielectric with 2 leads coming out. Only thing that makes it non-inductive is they have multi-strand leads instead of a solid wire. They had many strands, like 5 I think, twisted around each other, and that supposedly makes it non-inductive. Anyway, where was I? Anyway, I know where my parts come from. I know how they're wired in. I know where they go. I know what they're labeled. I know what the values are. That's all I need. So now, with that being said, most of this is probably going to get cut. I'm going to take capacitors apart. So, want to watch? We'll do another couple. Let me get you set up. Let me get you set up. I'll sing to you there too. Let's see. There we go. We're going to telephoto you in a little bit. Alright. Let me get my cell phone out of the way so it don't get damaged. Let's see. Put on my patented glove. Put this here chassis out of harm's way. Get that way over there out of the way. Oh, and I wanted to tell you something else. This here is a resistor of all things. A wire resistor. Not a wire wound, it's a resistor. It is open. It looks like it's yellow and red, but it is open. What I'm going to do, I'm just going to, this resistor is probably 8 inches long. But it started out in one circuit, went all the way down to one end, come back to about a 3/4 inch way to a ground. I'm just taking this out, replacing it with a fixed resistor. Anyway, I digress. So let's, I'm not saving the wires off of this. I don't know about y'all, but I have a bad habit of leaving my tools. I need that. Don't cut that wire or this lead. I'm too southern for my own good. Don't cut that lead. You'll need it. So let's get the heat gun. Remember, low heat setting. You don't want to just blast this thing with heat, okay? So I've got 1, 2, 3, 4, 5, 6 capacitors that we have to do. Let's see if we can get this done. Anyway, grab said capacitor with said pliers or your favorite holding device, and we're going to warm it up. Remember, low heat. You want to heat the whole body first. Don't get it too close. Just kind of like roasting the weenie, except you're not going to eat this. I mean, you can if you want to. What you want to do is you want to get it hot enough where inside will start melting, but you don't want to just blaze it. And that end there, you can't see it, but the end is starting to melt. I'm waiting on that plug to completely melt. It's turning into oh my God. There we go. Hey, I got a good blob out of that one. I'll be able to reuse it. Now, you can see the solder inside there. I'm going to do the opposite side now. Oh yeah, it looks good. Hey, I was able to save that one too. Well, hot diggity. I'm not going to disturb those. I'm going to hang on to those. I might be able to reuse this. So let's, next thing we got to do, now that we got the thing unplugged, got to go in here with our soldering iron, and let me get my favorite pliers or my favorite tool in the whole wide world. These little dudes. I love these. I got these from Harbor Freight. Boy, do they work. So I'm going to go down inside the capacitor now and try to remove the lead. I think I got it. No, not quite. I'll just pull it out. Alright, you got that one done. I'm going to bounce this one again. It got a little bit of... Yeah, there we go. Now I got that little foil. Ooh, careful. I got that little... That's the electrode right there. That's what connects one side of the foil to the other. Apparently they use compression. They don't. It's not secured to the inside of the capacitor in any way. It's just that little bitty foil strip, that little conductive foil strip that you could solder to. It's just wedged in there. It's just when they roll it, it's kind of just wedged in there, and the pressure of the capacitor body holding that coil together is what gives it the connection. If that makes any sense. If it does, somebody tell me what it meant. I'm just trying to pull it out because it's got to come out anyway. Get my favorite little pliers here. That's what I'm talking about. That just pushes in there. That's just it's just pressured. They use the pressure to hold that in there. They don't use any kind of form of connection other than pressure. So we've kind of learned how these things are made. Going to do the same thing here. Got a big blob of solder. You know what? Let's try something different. I don't think I even need to unsolder this, to be honest with you, because that is... Yeah, you don't need a soldering iron for this. Just grab it, pull it out with a pair of pliers. The whole thing is going to come... Well, I broke it. I got stupid, y'all. So I'm going to try to preserve that piece there. I might be able to repair it. I just got stupid. That's just bad habit of mine. Alright, remember that? My nut driver pushed into the end. Gonna heat it up. Remember, slow, low. Low and slow, buddy. Let's see where this one's gonna go. Gonna heat it up, kind of like heating up a weenie on the fire. Just kind of keep the heat going in circles and trying to do it this way here, you know. Try not to... Waiting on it to solidify inside. I'm waiting on to see little bubbles and stuff. Just keep it going in circles there. Try to heat the whole thing. Turn it a little bit at a time. Want to make sure it's nice and molten. Everything gooey and it's down there dripping, dripping, dripping. That thing is like a pain in the butt to turn off. See if we can push it out. I don't know, it don't feel right. I don't know, I feel like it's unraveling, y'all. Maybe not enough heat, maybe too much, I don't know. This might be a fail. Yeah, it's coming apart, y'all. Yeah, I don't think I'm going to be able to save this one. Well, it's coming out. Yeah. Yeah, I got it apart. I think I got it back together. It's a little worse for wear. I think once it cools down, I think it'll be fine. It honestly looks like a cigar somebody dropped on the side of the road, but I think it's intact enough to reuse, so we'll run with that. I'm not sure what happened. Maybe it's because I wasn't paying attention or was rushing it. I don't know. And here, then again, for the 100th time, it's what it looks like inside. It's just a roll of. You got a roll of wax. Here's one of the capacitor plates, if you will. Inside of it, and the other side should be down here somewhere. Yeah, there it is. You see that silver on one side, there's a silver on the other. That's what constitute two plates of thin aluminum with a dielectric, in this case wax paper in the middle. That's what makes a capacitor. And that's how they adjust the value of how much of that foil's in there. Okay, so we got one of those done. It looks a little worse for wear, but I think it's going to be fine. So, alright, let's go to the next one. See if we can do a little better this time. Tell you, hang on just a minute. This is annoying. See that cover on there? Let me pull that off. That is such a pain in the butt. There we go. Oh my gosh. Oh wow. That was such a pain in the butt to use this thing. You couldn't, even without a glove on, it was still a pain in the butt to use. Alright, let's see if we can get them plugs out. Matter of fact, let's not get crazy. Look, I'm going to show you something. If you can see it. That come out. That's the little wax plug. So what I think I want to do, if I had something to put this in, I want to put it, if I can get them all out like I'm just put them right there. I'm going to try to save these wax plugs. I might be able to reuse them if I can get enough of them. Alright, let's carry on. I digress. We'll heat this capacitor up. I'm about to heat it all up at once. I'm wondering if that's doing more harm than good, honestly. What I'm doing here. I don't have it gripped quite like I want it. There it went. There it is. Kind of ungraceful, but it came out. Put that down there in the collection bin. Yep. Try this side now. Oh, got that thing on high power. I don't want that. Now, let's see if we can get that out. I really want to grab it in my hand. Now I'm going to drop it on my good clean floor. You ever had them days, guys, that just everything wants to be a jerk? I'm going to hold it with my hand. Try not to burn my fingers off. There we go. There we go. That worked. Alright, now we're down to the solder part of it. Remember what I did a few minutes ago? I didn't like that. I'm going to put it back in the vise and do it like I did the first one. I think I had more control of it like that right there. Ooh, I'll put my glasses right there in harm's way. Asking for it. I don't want to. That's what I did a minute ago. Is when I just pulled that pin out, I didn't realize the leads were still on it, and it just pulled the end out of the cap, and that's what was holding the whole thing together. So I won't do that again. Take the leads out with solder, and then take the solder out. One lead. That's what this is all about, learning. You learn from my mistakes. See if we can make this one work good. I'm just going to find the lead there. Get my fingers on it without tearing up something. Alright. Unsolder that. Boom. Unsoldered. Now that I got that done, now I'm going to take and melt the solder inside. And it just kind of just jumped out. It couldn't wait to come out. Just taking the solder off to make it easy to grab that little foil strip inside there that does the connections. Alright, now that I got that done, you know, I don't think that even needs to come out, to be honest with you. It doesn't need to come out. I'm not going to take it out. I think it'll just make it a little bit easier to take out. So let's go ahead and try heating it up again. Can y'all see what I'm doing, I hope? Try not to overdo this. Get it too hot, it'll want to come apart. We don't know, guys. There we go. I don't know exactly what happened there. I don't know if the capacitor came with it. Not sure, guys. I think I messed this one up. I think it just... How is it you can do one and can't do another? That's what I'd like to know. Oh, this one here. This one ain't looking good for the home team. I'm going to try to heat it up again. I'm okay with a little full left behind. I think I got it back together, folks. It looks a little rough, but well, that's three. Let them cool off here. I know that foil held on. I don't know why it did that. Could have been because I didn't pull them strips out. That's the third one that third capacitor that I've taken apart. Out of three, I got one perfect. So what do we do? Do we just keep on trucking? I guess so. Let's keep on trucking. Heck, you know, in for a penny, in for a pound, right? So I'm going to do it a little different. I have a little more control of it. I'm going to hold it in one hand, as you can see. I'm going to put this thing on maximum power. Let's get this little nugget right here. It's going to come out. A little piece of wax. And now I'm going to heat the edge of it. Try to melt that little plug. That little plug out. I'm trying to get it out intact. taking me with it. Oh, there it comes. There it comes. It came out intact. Awesome. If I can do the other side. That's what I want. I want that plug, that I might be able to reuse that plug that come out of there. Instead of using hot glue. But I may just use the hot glue because the hot glue gives it stability, strength. I'm not hitting the capacitor on the table. I'm using the butt of my hand to do this. Alright. Still intact. Put it over here and hold it a second. I don't know if when I'm pulling this thing apart, if I'm using too much heat or not enough. See if I can pull the leads out. Okay, got the leads out of those now. Now I'm going to get some of that loose solder out of the middle of it. Okay, well, let's see if I can get the little metal strips out of there without damaging this thing too bad. Let's go to a little bit more precision here. Wish you could see what I was doing inside here. You see the little metal tab? Basically, when they're making these things, apparently they just roll them up in there and just pull out. There. My thinking on this, now that I think about it a little bit, I think the reason that I need to pull these things out, because they take up, they kind of, because there's compression fits in there. So I think, trying to think, do I want to do this a different way? I don't know, guys. What do y'all think? Of course, by the time I read the comments, look at there, perfect extraction. I didn't even heat it that time. So apparently what I asked a minute ago, was I using too much heat? Yes. I didn't even have to do that. I just pushed it in there as it was cool enough for me to hold my hand. It was cool enough to hold my hand, I guess I should say. And I just pushed it out and it came right out. So, 2 for 2, guys. 2 for 2. There's the guts of that one. Well, let's see. I got 4 capacitors taken apart. I got 3 to go. Boy, that's 7 caps. So here's a couple more of them plugs, if you can look there. Getting a collection. I guess if I keep doing these things long enough, I'll have me a big collection, and I can be the star of the show. Making a gigantic mess. Here we go. Let's see. Extracting wax. Take 5. Again, I'm just warming the end up, trying not to take my finger and cook it. I don't like eating finger. I hear it tastes like chicken. Again, I'm just getting it hot where I can see it kind of moving around in there. I'm trying to keep the heat down. I think I hit it. I think I hit it with my hand. That's a little toughy there. Let's just rotate it a little bit. Okay, that didn't want to come out. It wanted to be a jerk. Okay, no problem. Thank goodness I got gloves on, right? Brand new glove. I bought 10 pair or 8 pair for $10. I forgot where I bought them from. That's kind of warm. It builds up in your glove after a while. Come on, dude, come out. There we go. Look at the tips of my glove if y'all can see it. Don't wear your best gloves doing this, I can tell you that right now. Alright, now that we got that done. Ooh, this is an adventure, yeah. Alright. Take our trusty old soldering iron and we'll go ahead and pull the leads out of here. I need to clean that up a little bit. I hope y'all can see. Y'all can't see me right, can y'all, what I'm doing? Let's pull you up a little bit. Just heating that little strip up in there. It's got that little touch of solder on it. Now we'll take, flips it. Got that one out. Now we'll take the whole thing back out. Go ahead and solder. Alright, got that out. There. Okay, dokie. Now, little strips in there. See if we can get that out. It's really delicate stuff, guys. It really is. You don't go in there like a bull in a china shop like me. I'm just kind of damn the details and do it, you know. The sidewalls of the outer parts of this thing are really fragile. You just want to pry it up somehow or another so you can get these pliers in there. Reach in there, you pull that strip out, make sure you got to get that out. Now remember what we did a few minutes ago with our tool. Let's see if we can do this again. Yep. Look at there, another core. Looks like another successful extraction. That was easy. Have we got a system down yet, guys? It looks like it. So I've got 1, 2, 3, 4, 5 capacitors, cord. Oh, let's call it that. Let's call that cord. 2 to go. So here we go again. I'm gonna pull the ends out. Yeah, I'm feeling it now. I didn't realize it until just a few minutes ago that I was actually hitting my bench with this capacitor, which is not doing it any good. I don't really like pointing that heat gun at my finger. Okay, that side done. Now, whoop. Try not to grab this thing on the end. Wax gets hot. Trying to heat it on the edge. Trying to get it to where the heat from the outside in, putting on the. Just when I think it's right. Core almost ready to come out. There it went. I'm glad, because that was getting warm. Alright, you know the step. Next, put it in the vise. Tighten it down. My gloves are like, hey man, what are you doing, dude? I haven't figured out a way to do the resistors yet. I don't know. Like I mentioned before in earlier videos, these dog bone resistors are ceramic cores. I experimented with one the other day. I didn't really realize it was just a bonehead moment. Whoop, got another one there. Didn't see it. Bonehead moment. I wasn't thinking that those were ceramic cores. I mean, what else would they be made of? I was going to try to drill through it, you know. Drill through it, you know, drill a hole through the middle of it, big enough for put a modern resistor through, and then just tack the thing back together, you know. It didn't work out that way. When the bottom come off the resistor for whatever reason, when I had it in the vise, right, and the bottom of the resistor came off, and then I saw, oh hell, this thing is ceramic inside. So that was that. So I don't know how easily to duplicate one of those resistors, because the ends of those resistors are molded lead. I'm just holding the middle of the capacitor base with my hand, because look at there. There's another one. Perfect. Well, y'all suffered through 1, 2, 3, 4, 5, 6 of these things. Y'all want to? I'm going to let you suffer through one more. Okay? And this is old number 9 right here. And I'm sure there's an easier way to get this waxed out. It's just this is more easy for me because it doesn't hurt me. Because I don't know how to say it. I've got these gloves on. They've got leather tips. I know where to point this thing. I don't just point it at me willy-nilly most of the time. Okay, I guess that's good enough. What I should do is let it cool down before I grab the other side. But anyway, I'm ready to get through with this part. Like I said, use low heat, guys. Wear gloves, some good gloves. Don't go out and get none of these little latex gloves, none of that stupid crap. Get you a good set of mechanics gloves that you can, that's got some thick finger pads on it. That way, use you a good heat gun. You ain't got to get crazy with it. I'm going to do a little more. There. Alright, that part's done. The loud, obnoxious noise is over with, I think, other than me talking. Alright. You know what the next step is. Put it in the vise and unsolder the leads out of it and pull the leads out. Deleting, coming up. Delete, delete. That's, you know what the Pink Panther does, you know, to his files, right? Delete, 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 delete. Okay, a corny joke of the day, right? I love the old 60s Pink Panther. I don't like the modern stuff or the later versions. I like the Depatie Freeling. Okay, got that done. Okay, I can turn the soldering device off. Done with it. Alright, now I got the then we'll pull the strips out, the connection strips, terminals. Got to bend it up where I can get to it. My little pliers reach down in here very gingerly. Pull them out. First, turn it upside down. Do it again on the other side. You probably don't have a. Some of you might not know, have a clue what the hell is that guy. Ooh, I put too much pressure on the side because I'm running my mouth. But there's no clue what the hell I'm talking about. Well, you ever do one of these things, you try to pull your first one, you'll know. Yeah, that's what it looks like. It kind of just reminds me of a firecracker. Alright, let's see if we can be lucky one last time here. Something moving, I ain't sure what. Wow, that's really successful, guys. Another success. The first one that I got out was a fluke. Don't know how, but at the 3, these three here, they're still intact. They just kind of look crappy, but they're intact. So they're going to look crappy, but that's okay. They're still the original shell. Okay. So I did 4, 5, 6, 7 capacitors. I ain't sure how long it took. You saw how I did it. I explained the best way that this redneck knows how. Okay. So this is the first one I did, and it has solidified greatly. I don't think it looks bad with the hot glue. I really don't. And the hot glue gives it more strength, I think, mechanical strength where it needs in the ends, because these capacitors, the leads come out the edges, not like you saw the new capacitor a while ago, and I showed you how to test them, how the leads come out the ends. These come out the side. So you put that wax in there, now you don't have nothing to give you any strength, mechanical strength. I think in this case, I'll know when I start installing these capacitors, but like where this cardboard, I guess we're going to call it cardboard paper, was kind of damaged because I was not watching what I was doing. It gives it all strength. It binds it together. Apparently it bound. It ain't fell apart yet, so I'm going to run with it. So I'm going to shut this off. I'm going to clean my workbench up, take this glove off, just kind of straighten up and sort these capacitors per value and see if I can finish them up, and I'll come back. I'll probably do the last one I do if I get to. I'll do the last one, see if we can do it in a little bit better detail to show you what the heck I'm doing. Alright, see you then. Bye. Anyway, what we're going to do now, we got all the capacitors cleaned, we got them all. Oh, and I found out we got all the capacitors first off, and most of them come out of the RFIF chassis. Now, there's still several left over in the main chassis, which I'm not going to do today. I'll worry about them later, but I think I have enough time to do these. Anyway, I have the 101s. Let me see if I can get you over there. I have the 101s right here. I have the 101s. This is the first one we did. It was a 101. The 101 is, according to this, is a .047. That's a .047 that we stuffed. We took apart the old one, sucked the guts out of the old one, and put a new one in place of it. Good as new, right? So now we got 3 more. Alright, so and then we got the .1s over here. I got some miniature .1s. No, .01s, I'm sorry. Excuse me, .01s. Let's get to trucking. What do we got to do? Well, me as an editor of this video, do I want to show you guys? I tell you what, I'm not going to subject. I'll do one more. I'll do one more of finding the shield on this thing. So you're not going to see. I'm going to move this camera over because I can't see the view screen, and it just messes with my head. Alright, let me telephoto you in a little bit. There you go. I can't see the view screen good, guys. No, oh, fail. Okay, let's try that. Alright, what are we going to do? First thing we got to do is we got to identify the outside foil. I'm not going to go through all that again for telling you what it's for. The outside foil is what you want to determine. Alright, so now I can't see this thing to save my life. Alright, got the setup. Gonna put my finger on it. I'm gonna look at the trace. I can barely see it. Alright, I'm gonna flip the polarity of my scope probe on the capacitor. Look at there. It's at least twice as high. That tells me that that is the foil. There you go. This side here that's got the negative probe on it, wherever the heck it is, this is the full side. or the, not the full side, outer full. So, where in the devil is it? Put a little dot on it. Okay. May as well do it for the rest of them. So here we go. Just because if you have a bunch of these and you just look at the, oh, okay, well, it's got the fulls on the end of one end of the capacitor with the markings of, you know, certain writing on it. That don't mean it's the same on the next one. Anyway, there's my signal. I can already tell you. Very important that you keep your fingers away from the leads. You just want to touch the body of the capacitor. Just kind of pinch it. Keep your fingers away from them leads. See that how it went up? There you go. This is the outside full right here. That's the outside full. It's connected to ground of the scope, which is shielding my high sensitive input lead of the scope from all this noise floating around. So I've already identified two. I hope this is making sense, guys. I get so carried away. Alright, let's get all this. Try to keep everything. Alright, if you can see the scope level. Let's see, trying to keep my fingers away from these leads, because if you have your finger too close to the to your positive scope probe, if you can see that level, see, that's twice as high as that. I'm going to call that now. Mr. Carlson has made a little device that that you just put the capacitor in there and it does this little flip-flop thingy and it identifies them for you automatically. You can go over to Mr. Carlson's web YouTube page and find that, and he's got a lot of great videos. Anyway, we've identified that one there too. Alright, got it. And believe me, guys, it's not, if you have the tools, this is fun. If you don't have the tools, it's still fun. Alright, here's all the capacitors now. Everything is identified. We have these capacitor bodies here. So now, remember that full shield that we just found, you want it on the side of this little brown mark. If you can see that little mark going across? Oh, what is up with, oh, my battery's going dead. Hold on, guys. Oh my, the battery going dead, Ma. Hold on there. Whew. Boy, I've had this thing going long enough. It's going to be one long video. I'm going to have to edit the heck out of it. Okay, this is a 101. Okay, and the 101 is a 0.047 microfarads. So now what I want to do, I'm going to take the end that I've marked the dot with. I'm going to put it on the end with the line. I'm just going to push it in there. And my X-Acto out. Remember what we did a while ago is when I pushed it through that side hole, which is, remember the leads come out the side, there's the hole right there. When I tried to bend that lead, it just cut through that. So I'm going to try to just very carefully cut through that so I can just real easy Just cut through that hole, right? Cut through that. Make a little line in it. Where is it? There we go. I just cut a little line in it right there. Down to the hole. I'm going to do the same thing on the opposite side where the other hole is. Then I'll be able to push my capacitor in there. And then I can just go ahead and bend the leads. And then I can go ahead and use my hot glue, which the hot glue gun is to my right here. Standby. Alright. So I'm going to push the said capacitor inside here. Try to center it. I'm going to pull the leads up. Like that. Looking good already. Alright, going to take some of this here hot glue. Oh, this has got a lot of space left in it. I'm just filling it full of hot glue as far as I can get up the tip. It's kind of hot. Let it set for a second so I can flip it. Try not to scald myself. I filled it up to the edge. I think it's going to bond well. I honestly do. I'm going to try to let this set for a second. So when I turn it over, don't all just roll out. I think it's good. Let's do the other side. Not that I'm in a hurry or nothing. I'm making sure my dot's in the right place. Now what I did on the original one, I just took a gold, that's the only marker I had, that dark color, and I took a gold marker and just kind of scribbled on there and kind of darkened that a little bit. I think it's going to be fine like that. So what if it's got a little white showing through it? You got 90% of the outside of the old capacitor with you, so letting this cool off before I set it down and we can do the next one. I think it's good. Alright, I'm just going to lay it down on that paper. Let's go on to the next one. Same procedure, guys. Can you still see me? Good. Got to find the little holes, which I think that's it right there. Yep. Remember to take your X-Acto, cut a little line in it from the outside edge, work your way in. Don't be in no rush. Remember, these things are 90 years old. They're really fragile. I can't wait to get to them other three that we messed up. It's funny that those three there were the .01s. They were the one that give the most trouble. Anyway, marking the lines again. Put my dot, if you can see it. I'll put my dots on the same side the line is. Gonna push our little 473, which is a 047 capacitor in there, and I'm going to just bend the leads like that, and then I'm going to just real carefully bend the leads again. Alright, ready for another gluing. I'm going to double check, make sure my dot's on the same side of the line, which it is, so we're good to go. Alright, I filled it up. That looks a little better than my other one. I didn't fill it all the way to the end. Got to blow on it a little bit. Just turn that noisy scope off. It's pretty windy out here today. It's probably I don't know, probably about 65 degrees. Had a front blow through last night. It's still coming through right now. That's what's making the wind blow. But it feels really good outside. Deer season starts Saturday morning here in Louisiana, or in the area too, the area I'm in. I'm ready. Gotta go to the store tonight and get a few more supplies, but making sure that's solidified enough to set it down. Yeah, I think it's fine. Oh, did I get that? There. Another one done. Now we have 3 out of 4 of those type particular ones. This is split a little bit where that where the lead hole is. I think what I'm going to do, yeah, we'll try it. I'm just going to maybe move it over and cut that line. Well, we'll see. What the heck. Alright, goes the next one. Again, there's the dot. There's the line. Okay, that one's done. Let's see if we can. This other side's kind of. There we go. I did it. Wow. Alright. I like this. This is really fun. Turning out better than I anticipated. I don't know what this capacitor thinks about it, but it's capable of 105 degrees. Hopefully I ain't melting the capacitor. I can get them done here in a little while. I guess we can put them on a capacitor tester. I gotta let this one cool off before I flip it. Like it's good. I'm starting to turn white. No. All right. Now, if I ever have to change these capacitors, I ain't sure what I'm going to do because it's a little more secure than that wax. And that may be why other people use wax in theirs, but if the capacitor goes bad, it'll probably be somebody else's baby. Alright, that one's done. We now have four of the 101 done. Now it's time to move on. Yeah, it's time to move on. C11, 13, 14, and 18. I got the little small capacitors, 0.01 at 630. It's amazing how much technology has changed over this 9 years since this radio was new. And I'll show you. Get all of them but one. This is the same. That's 1933. That's the size of that capacitor. Same thing nowadays. Look at there. Something, isn't it? Now that there is going to be interesting putting glue in because that capacitor is smaller. What do we do next? Well, you guessed it. We got to identify the shield side. Same procedure. And there, a little bit more signal. Let's see if we can get you pointed at the scope. Sorry about my fingers. Alright, here we go. I got it in there and I'm looking. Yeah, it's about, what is that? Let's see. 2 millivolts per division, so that's 4 millivolts. Oh, look at there. See? See the difference? Come back. Fix that. See? See how easy that was to identify? You're looking for the smaller of the two signals, and whenever you get a smaller of the two signals, wherever your ground is, that's where your full shield is. Again, put your little notation on there with a black marker to tell you where it's at. No biggie. And done. Let's go ahead and do the next one. Alright, that's two divisions. 2 millivolts per division, so that would be 4 millivolts. Now we're going to just flip it. Look at there, so much higher. We'll swap the leads back. See how low it is? There you go. There's your full. Man, stick with me, you learn something. Alright, one to go. Place your bets now that I got it right the first time. Let's see what we got here. Ooh-wee. Oh, that's the high side. I guess I would have lost that bet. Y'all should have betted. Alright. There you go. We have identified those now. Alright. That was fun. Hello. Alright, let's finish this up. Remember, where is my work surface? There's that hot glue gun. There's my hen. No. Oh, let's turn this out a little bit. There we go. Alright, let's turn off the scope. Don't need it anymore for today. Love that scope. It's an analog scope, but it show. I wouldn't mind a digital scope, but I've got one for work, but it's a little old one. It's a piece of junk. So, these are the ones that we didn't turn out so well. I'm not sure how we're going to do this because it's going to take a little bit more stuff to fill this up with. The leads on this new capacitor is kind of skinnier. Uh-oh. Hold on. Alright. Well, I went ahead and did it. One side, I'm going to let it cool for a second. It had a little bit of wax still in there for this one. Like I said a few minutes ago, I don't know about the temperature of this, but I guess it's fine. It's not long term. Got that one done. It looks a little rough for wear, but I think it's going to work fine. I'm trying to just cool it off right now. Time to do the next one. Same drill. Now the holes don't align on this, but remember they come apart on me a while ago. So I guess we'll take the X-Acto. Trying to find where the old hole is. There one. Just made a little hole in it right there. Every dang, I actually found it. And I'm just going to cut a slot, I guess, in this one. All right, I got the dot lined up with the line. So I'm going to kind of make a little curve in this, and I'm going to try to push it up through that hole. Trying to center the capacitor in there best I can. All right. So what I did on the last one, I just kind of filled it up to where it kind of slow. That way it would kind of congeal. Because the capacitor, I may have to do this in stages. I'm going to do it in stages. Because the capacitor is smaller than this one, ought to work a little bit. Oh, this one is a rough one here. This looks rough, but I guess it'll work. So let me put a hole in it. Find the minus or put the field. Shove it through there. Yeah, this one's the roughest one. I think this is the one where the foil of the capacitor, the inside of the capacitor got stuck in it. So we'll fill it up, get it started, get it where to plug off, and then we'll come back. I'll let that set for a few minutes. Come back over to this one. Almost done. Alright. This one and the other one turned out alright, but this first one, that second one I did, I think it was, or the first one, messed up really bad, and the shield, you know, the foil got caught in it that y'all tried to just pull apart. That is a little bit more of a mess. But I'm going to do the best I can, what I got. You know, what do you do? Still 90% old, original as far as looks go. But them other ones ought to be cool by now. As soon as I get this one done, or I can set it down, we'll take a couple of them new ones and go put it on the tester. Make sure it's good. Ouch. Tip of these things are hot, so just be warning you. Alright. I filled the bottom up. I don't think you could see it, but I filled the top up, and I just kind of let it sit. Okay. I think it's good to sit down. Alright. Let's turn our attention now to our capacitor tester. this IR stuff is, my capacitor tester. If y'all want to claim it, y'all can. Let's back that dude up just a little bit now. Alright, so these, what were these? 0.047, so it doesn't matter about polarity. So let's see, 0.047, so we're going to set the capacitance range 0.001 to 0.5. Okay, so that would be, where? 0.001, where is that scale? Right here. It's on the capacitance scale right here, 001, this middle scale. So we'll just put it down here low. What we're going to do is test capacitance first. So we'll just put our patented probes on there. Don't really care to see what that does. So you're looking at the eyeball here, so I'm going to turn it. Ooh, got a solid null right there. And it's almost at the 0.05 if you can see it. Oh boy, taking you off a ride. Let's see. Let me put you right there and you can see the eye. That better? Yeah. Watch the eyes, I spin it. Look where it's at. Almost 0.05 right there. So the value's good. So let's test it for leakage. We're putting it on the leakage scale here. Let's widen it back a little bit. Press the switch. Yeah, it's good so far. Good so far. 250 volts, still good. 350, good. 450, good. Ding! That capacitor is safe. It's a good capacitor. Do the same thing with this one. We're going to go back to value. We'll turn it. Yep. Almost exactly where the other one tested. Now we're going to put it back on leakage test. Good on 25. Good on 150. Good on 250. Going up to 350 now. Good on 350. There you go. I don't think the heat bothered these too much. Now let's get those 0.01s we just did. See how they fared. We'll just spot check a couple of them. These are 0.01s at 630 volts, I believe. 630 or 650, whatever the heck they are. Let's see how these fare. So we'll go back down 0.01s. Let's see. Should get a peak right about there, and yep, exactly 0.01. Ain't that amazing? So go to leakage, 25 volt scale. No leakage on 25, 150, no leakage. Yep, 250, no leakage. Alright, 350, no leakage. And 450, which is the highest this rig goes. So that one did good. We'll do this one here. Go back down. We'll check it again. Look at there, almost exactly where the value of the other one was. Almost right on the button. Let's go back to the leakage scale. 25 volts. Nothing. Nothing on 150. Nothing on 250. Nothing on 350. And nothing on 450. So, a success, ladies and gentlemen. Like old Justin Wilson said, what you know about that, huh? Oh, that's an ugly picture. Alright, well, let's see if I can sit in my chair without busting my butt and y'all getting a big laugh. Well, that's that. I really don't know how long this video is going to be. I'll see what I can do about trimming it, but we were able to make 7 capacitors, restuffing 7 capacitors from a radio that was made in 1933. I successfully stuffed old capacitors. That's something else I've never done before. So I claim it a win. I hope you guys will share this experience. Hope you guys enjoyed this. I'm sorry it was so long, but you know, it's just, to me, I found it fun. And if you're an enthusiast of radio, these old radios, and you want to do this stuff, you saw how I did it, and you see how they turned out. You see all the different things that I did, how it worked, what did work, what didn't work. So these are good to go.